Week 5 Task 1 review. I am going to put all of this in one video for you so that you can review all of it at one time. If there are any things in this video that you do not think you have seen before, then you need to go back to Week 4, Task 1 and 2, and rewatch those videos. So problem 1, identify the domain and range of the graph below. So the domain, remember, is your x values. In this graph, my x's go side to side. You can see the x-axis is labeled down below. So your x's go from left to right. So I know that domain needs to have an x in the middle. Now, all exponential functions have domains of all real numbers unless they have these endpoints right here. So these x's are going to go from -1 all the way to +3. And remember that your assessment is going to be multiple choice. So you are just looking for these pieces. You're looking for x's because it says domain, the numbers that go along with it. Your range would go the other way. So your range is your y's, and it would go bottom to top. So the bottom is going to be at 6 and the top is going to be at 27. So if you were asked for range, you would look for ones with y's and then those numbers that your y values are at. Number 2, Martin opened a money market account. Martin's investment account balance to the nearest dollar can be determined using the exponential function f of x equals 1,000 times 1.06 raised to the x, where x is the number of years the money is left to grow untouched in the account. Which of the following best represents the meaning of the value 1.06 in the function? So remember last week we talked about you have your initial or your starting value. Then you have 1 plus or minus your rate, and it is raised to the time. So in this question, they are asking about that number 1.06, which is going to be 1 plus our rate. So notice it is bigger than 1. So that means there is going to be a growth. So now I'm looking at my answer choices for something that says growth. The rate of growth, well, this is a rate and it is growth, so it could be A. Number of years, no, that's going to be our x value. Remember, it says x is the number of years. Initial deposit, no, that would be the 1,000. That would be the number in front. Number of times, nope, we haven't even talked about that. So A, the rate of growth, I know it's growth because it's bigger than 1, and I know it's the rate of growth because it is the number in parentheses that x is being raised to. Number 3, scientists are studying a bacteria sample. The function f of x equals 245 times 1.112 raised to the x, which gives the number of bacteria in the sample at the end of x days. Which statement is the best interpretation of one of these values? So let's go ahead and interpret some of these. This is our initial or our starting number. 1.12 is 1 plus 0.12, so that would be a growth. And then remember to turn it back into a percent, we un-Beyonce it. And then x is always going to be time. So let's see which of these looks like that. Initial number is 12. No, we said our initial is 254. Initial number decreases. Well, it's not decreasing because that rate is bigger than 1. The number of bacteria increases at 12%, that's true, and then the number of bacteria at 1 day, no, that's false, because this is not at the end of 1 day, this is where we start. So H is going to be my correct answer, because I'm starting at 1 and I am adding 0.12 to get a growth of 12%. Number 4, the rate at which cell phone subscribers increase per year after 1985 is given in a given city, is modeled by the exponential function f of x equals 285 times 1.75 raised to the x. James was asked to tell the meaning of the value of these numbers, which would be the best answer. So 285, is again going to be our initial. 175 is going to be 1 plus 0.75, so that's going to be a growth of 75%. So 285 represents the initial, that's true. 1.75 is the rate of increase. That looks true. Let's see if there's anything else. Yeah, new subscribers. So 285 is the current subscribers. Well, no, it's not current. It's what you started with. So that would also mark out H. 285 is the population in 1985. Well, no, that's not right because these things are representing the cell phone subscribers, so it's not the population, so that would definitely be F. Number 5, Ms. Hawkins took 300 milligrams of migraine medication before school started. The drug has a half-life of 1 day. Write an equation to represent the amount of drug left in her system as a function of the number of days that have passed. So f of x equals, remember we start with our initial, we start at the start. So 300 milligrams. Then we have our rate. Now this one says a half-life, meaning that your rate is going to be 1/2. And then that's going to be raised to the x for a number of days. That's all we're doing when we're writing these. Number 6, domain of the exponential function f of x equals 1/4 times 5 raised to the x. Remember, domain for all exponential functions is infinitely many, or you might see it as all real numbers. Okay, so your domain is always infinitely many or all real numbers. Just a bonus for you, range should be all positive real numbers. Because remember, like we talked about in task 4, your exponentials go like this or like this, and they will never ever go underneath. Number 7, Sarah invests her graduation money of $1,750 in an annuity that pays an interest rate of 6% compounded annually. She wants to determine the amount of money after she leaves it and does not make any deposits or withdrawals. Which of these will show her growth? Now remember, growth is rate plus your percent. So this number is not bigger than 1, this number is bigger than 1, this number is not bigger than 1, and that is not even a number. So G is the only one that even has the right answer, or the right option for growth. You start at 1,750. We would do 1 plus 0.06 because we would take 6 and Beyonce it. And it would be raised to the x, and then this simplifies to 1.06. Number 8, in the year 1900, the total number of metric tons of copper produced in the world was 495,000. Each year since 1900, the total number of copper has decreased by half over the amount produced in the previous year. Which function models this data in years since 1900? So all 4 of these are all starting with our starting, which is good. All we're really looking at is our rate. Now if you notice, C and D, we have never seen a function written like this. All of these exponentials, the x has been in the exponent, so it's not going to be C or D. So we just have to figure out A versus B. A is representing growth, where B, is representing decay. Now this tells me it has decreased by half, so I need a decay function that is going down by half, so B is going to be my correct answer. 2 last problems for you. Number 9, determine the domain and range in the function if A is 1/3 and B is 4. So we have 1/3 times 4 raised to the x. Remember, my domain is always all real numbers or infinitely many. For the range, I'm going to plug it into y equals and take a look so you can follow along with me. Alpha y equals inner 1/3 4 raised to the x. I'm going to take a look at my graph. And if I look at my y values, they get really close to 0, but they never ever cross, which is what all of your ranges should be. So y is going to be greater than 0. It will not be equal to. Your asymptote, if you are asked about that, would be your range, but with an equal sign instead. So your asymptote should be at 0. And then they ask you just to draw a quick graph, one thing representing growth, one representing decay. So growth is going to be increasing, decay is going to be decreasing.